That's what I was afraid of. We're gonna mute ourselves. No, I'm not gonna mute it. I'm gonna go like this. So we don't have to listen to me talk. Which one's it coming through? Both of them? We have one student joining us. So yeah, so Riley Klein is I don't think she's here yet, but lucky her. I want the sound to stop though.
Oh, my brother goes there. It's lucky support.
How can I get me to shut up? She's not on yet though. I'm okay with it. It's just I don't understand. All right, I got some feedback. So just give me a second. And other Riley's joining us too. Hi, Riley. Do you hear a bunch of echoes?
Yeah.
Okay. Go ahead and mute yourselves. Oh, God, it's terrible. What if I turn? All right, those of you joining us at home, hi. You don't have to, except for Miss Klein, but you can if you'd like. You're going to see similar stuff tomorrow, so that's totally up to you, whatever you decide to do. You can stick around with us or not. Okay? Totally your choice. If you want to stick around, I'd love to have you, but you certainly don't have to. All right, we're going to get started here in just 1 minute.
Mr. Rosengren, I have a question.
Yeah.
Are we doing the same thing in class tomorrow?
Say that again?
Are we doing the same thing in class tomorrow?
It should be, yeah, it should be about the same, so you don't have to be here.
Okay, well, I have to go then. Thanks, Mr. Rosengren.
Oh,
Hey,
okay,
bye.
yeah, bye.
It's weird because the sound on my iPad is all the way down.
No, I have no idea who I am.
I can share this screen, but it's not letting me share this one. Oh, who's that now? There it is. Ta-da! Okay, good.
If there's a way that works for you, I'm just giving you guys options. Yeah.
Yeah, I don't know why. So somebody left their AirPods in here 2 years ago, and it's called white chalk. I just left it. And now they're mine.
It's a lot. You're a boy.
I don't mean either. I don't know.
Is that my face?
Yeah.
All right, take out your work for 1.2b. Did we look at A already? Let's go. 23, 24.
Yeah. We were going to on Monday to get 1.2 days.
This is the only one that was
Just
we have homework.
yeah. Well, it wasn't listed. You do 1.2. I got 1.2.
Sorry for the sound.
It says it's not due till tomorrow at 11:59. Doesn't the message, it says due before next class.
Did I do it?
Yay. I'm guessing 1.28.
Now, let's see if it works. Oh, it would help if I pulled up the answers. Now you can see how crazy it is on our side.
4.5.
The level of class. Okay. Take a look at that. Obviously, I am checking things via Canvas when it comes to actually grading things and how you did, but I want you to just take a look and see how it went. My hope is that Riley at home, that you can hear me. Let's make sure that that's true. Sorry, pause quick. Let me just go back, I'll freeze it. Let me make sure this Bluetooth is hooked up. Connected. Okay. So take a moment, look through that, and let me know how you feel. Riley at home, can you hear me?
Yeah, I can hear you.
All right, so I'm going to put this in so I can hear you too, in case you have any questions.
Okay.
Can you see my screen, the homework?
No,
Okay.
I actually see the Bluetooth.
Say that again.
I see the Bluetooth connection.
Oh, true, because I froze that screen. Thank you. All right. But you can't see my screen, so that's good. All right.
Yes, I
Now, you should be back. Okay, cool.
Okay.
So I will try to do all of the zooming in on there, but just tell me, because I have you in one ear and everybody else in the other.
Okay.
And you can see this one, and you can see Grace.
You're welcome, by the way.
Yeah, lucky you. All right, so take a look. So some things that I did that I thought were worth mentioning. 55 and 57, I did give two versions of the same thing. I have a preference for 57, definitely the first one, right? Just the set of all t such that t is not equal to 0. And see how I had to use t and not x, right? As a function of t, not a function of x. So you have to choose the correct letter. Y for 58, like s of y. I think that's a terrible choice for an input variable. So we're going to try to avoid that as much as we can, but it's going to happen. So that's kind of why I picked this one, because that does happen. But for 57, like if you wanted to do the last version, the set of all t such that t is an element of, and then go negative infinity to 0, union 0 to infinity, sure, go for it. Not wrong, it just seems like more work, right? But for 55, let's do it over here. Alrighty. Have you seen that symbol before? That glare is terrible. Let's go down here and let's pick something that's not blue. Yeah. Yeah, that big R, kind of two lines coming down and kind of loops, right? That is the set of all real numbers. Riley, how's that color? Is that okay?
Yeah, that color's good.
Red's okay. Loose things.
That's
Okay.
good.
So if you want to, 55, right, the domain, it's just quadratic. It's just, I can put in any x I want and square it, right? I'm always going to get an answer back. So I can pick any number I want. And you want to say negative infinity to infinity? Cool. That's totally up to you. But if you just want to say x is an element of the set of all real numbers, that's nice. Okay. Questions on those first three? Just wanted to touch on a little domain stuff, especially with the rationals, because we saw that on Friday. But the other kind of big thing that we saw on Friday was the difference quotient. And that's the end of 1.2, and we're going to do more today. We're probably going to do more on Wednesday to make sure difference quotient is done, because I was looking ahead. 1.3 we're going to do. It's symmetry, even functions, odd functions, like reflected over different axes. Right? If it's even, it's over the y-axis. If it's odd, it goes through the origin. We'll talk about stuff like that. So I think we need a refresher on that, but that definitely comes up on the See You Succeed final, or at least the exam, the first exam. But then I looked at 1.4, transformations, shifts, stretches, reflections. You did that last year, right? So we're not going to do it. Okay. 1.6 is inverses. Like take y and x and switch them, right? And then solve for y. You did that last year, right? We're not going to do it. Okay. There's only one thing in 1.5 that I have to talk about, and we'll get there when we get there. But I'm going to cut out a good chunk of chapter 1, which will just give us more time to do new stuff. And instead of me sitting here teaching you how to do a horizontal shift by 3, like you did it. You're good, right? Okay. If you have no idea what I'm talking about, or if you want a refresher, that's an outside of class thing, and I would love to talk to you about it. Okay. However, the difference quotient is something we're going to spend some time on in class. So if you got yourself pretty far, or you got all the way in 82, 83, and 84, that's awesome. 84, definitely the tricky one with x cubed there. And so if you were lost, or if you went the long way and you did x cubed plus or x plus h times x plus h times x plus h, hopefully you got to that same part. But I really want to talk more about how to save you lots and lots of time, effort, and kind of tweak something we talked about on Wednesday and Friday in terms of how we want to write our answers best. My hope is that 82 and 83 at least went okay. But if they didn't, that's okay. We're going to do more today. I want to do more with you today. I want to almost recap Friday's difference quotient, practice it in here, give you a little bit of time to start some domain and range practice and some difference quotient practice, because after today, difference quotient will keep going, but domain and range, done. I feel good about it. But my initial thought last night was that we'd have enough time to do all of this whole big practice, like you doing all of this. I'm going to give you this much. And I was like, oh, they'll have plenty of time. And then second period happened, and we had like 10 minutes. And it's not 10 minutes worth of practice. So call it, it'll be due tomorrow at midnight, not today. Okay, so call it your job for tomorrow as well. So we'll start it here. You'll finish it tomorrow before we get to class on Wednesday. Cool. Okay. Questions about what's up there in terms of solutions right now before I kind of start again with difference questions? All good? Okay, cool. So I'm going to leave this up here so we can look back at it if we need to. But I do want to start almost from the beginning. I don't know. Riley, can you see me? I don't know. I can stop presenting. How about that? I'll stop presenting the screen. This is a new kind of adventure. I kind of like it. This is being recorded, by the way, so if there's stuff that you don't get in class, I'm going to make these recordings available, so every one of our classes is going to be recorded. The only audio is coming through here. So if I'm far away, you can whisper terrible things about me and I won't know. But if I get close, you gotta watch out. We'll go like this so we can make sure things look good. Hi, Grace. If you want to scoot back a chair, it's clean, I promise. Nobody sat here. Yeah. Okay, cool. Let's talk difference quotient. Okay, domain and range happened. I know we're probably good there. You'll get more practice today, tomorrow. I don't know what's worse or what's better. I'm just going to talk loudly so Riley can hear me. Okay, here we go. Difference quotient. Okay. If you took notes yesterday, you probably don't have to write what I'm about to right here, but I'm going to start some different ones. So you can look back at it and make sure that your notes are as full as you'd like them to be. That says difference quotient. It is so weird to look at myself. Hi. Okay. So the first thing I need is they have to give me a function. I have to start somewhere. And so let's just go for one. Let's call it example one. F of x equals 5x plus 3. I got him over here too. I'm gonna have way too much fun with this. Okay. Step one, done. We're good at math. Okay, step two. Evaluate the difference quotient. Okay. And it's not up to you right now to be able to cover up your page and know exactly how to describe the difference quotient. But I'd like you to try. Don't look. See if you can like put it together with me. Okay. See if you were right. If you're at the point where you recognize that, great. If you're at the point where you knew that, even better. But you don't have to be able to do that until the end of next week, because that's probably when we'll take our chapter 1 test. Sometime towards the end of next week, okay? Because 1.2 done by the time we start class on Wednesday. 1.3 we'll probably finish, and then 1.5 I got to touch on something on Friday. We'll review, we'll practice, we'll get ready. Okay, here we go. So step one done. Okay, step two. My job is to do this, right? My job is to substitute. Right? Substitute in f of x plus h. Substitute in f of x and see what we get. And so, like, my question is done right there. Now I start my own work. Riley, just tell me if things aren't colorful enough for you, okay? So I like to write it again. F of x plus h minus f of x all over h. Because if I can tell whoever's reading this how I'm beginning, then they know what to expect moving forward. But if you just kind of jump into a fraction, I don't know where stuff came from, especially if you make a mistake, then I can't give you that extra point or half a point there when you did that. Okay, here we go. So I create a train of equality, and you can go side to side, kind of typewriter style. When you run out of space this way, then you slide down and keep going, or you can just work vertically all the way. Use your space however you want. Some people like to work in columns, like I'm going to do all my work for this problem over here, and then all my work for the next problem over here. That's totally cool. Just be neat and organized so it's easy for you to read. All right, my job is to first do this. And since this is the rule for f of x, and they want me to do x plus h, my job is to change every x in this problem, and there's only one, so that's good, from x into x plus h. Okay, and when I'm substituting, I'm always going to use parentheses so that I'm being careful. Okay, and so I like the black, it seems to stand out. What's circled in black right here is what I'm about to do first. Okay, it's just change that x into x plus h. And that's the only thing that's up there right now is f of x plus h. Okay, and I know that doesn't mean a lot to us right now. I know it doesn't like give me much information about why we're doing this. Okay, I just need to build an algebraic skill, and then don't worry, you'll get the why when we get there. So thank you for your patience. All right, that's it. That's all that's in black is what's circled there. Now I need to subtract something from that. There's a difference, right? Difference squared. And what am I subtracting? Well, whatever f of x was. Whatever is already given to be. I don't have to make any changes to it. It's just 5x plus 6. And let's put that, of course, all over h.
if you understand the first step, the rest is just algebra. Okay, if you understand that f of x plus h just tells me wherever I see an x, I'm just going to put an x plus h. Like, don't do this. Like, don't write this. F of x plus h is not, unless you feel like writing it, but could do it separately. F of x plus h is not f of x, and then like tack a plus h on the end. It is not 5x plus 3 plus h. It is not that, okay? It's change the x to x plus h and then see what you get. Is that clear? Are we cool with that? Okay. I'll leave that there in case somebody wants to jot that. I'm going to work this way, okay? So I kind of ran out of space there, so now I'm going to come down this way. All right, so substitute, done. Now what? I want to make this as simple as I possibly can. Expand it, good, right? Let's expand this thing out. In other words, let's get rid of all parentheses by doing any distribution. Distribute / multiply, just get everything multiplied together. I have a couple things up top that I can do that, right? I've got this 5 that I can multiply in, so I've got 5x plus 5h plus 3. I'm going to bring everything down with you. And then you've got that minus sitting out in front of a set of parentheses, and that set of parentheses was crucial, right? I want to subtract all of f of x, and so you can kind of think of it like -1 times is really sitting there and distribute it that way. Really, you're just distributing a negative. We're just subtracting everything inside. You're just going to change the sign of everything in f of x. Minus 5x minus 3. My bar was a little too long, so I'm going to shorten it. Try to put that h about in the middle. And I'm going to keep going this way because I think things are about to get a whole bunch nicer. All right, expansion, done. Let's keep getting simpler. What else can we do to make things simpler? And what do you mean? Yeah, put things together that go together. Anything that we can do to combine some like terms, let's do it. Okay, so what do you see up top that we can combine together? 5x, right? So I got a positive 5x and a negative 5x. So what does that give me? Go on. What else goes together? 3 and negative 3. What do we get? 0. And so what's the only thing that we're left with up top? That's it, right? And h on the bottom. So drive me crazy. There we go. Last thing. Divide. I'm going to say divide away h. Really, we're dividing h. How can I say it? H over h is 1. That's what we're doing, right? Now, what we might have to do as things get a little crazier is we might have to factor out the h first as the degree of these functions get bigger and bigger. But this one, I don't have any factoring. It's just sitting right there. So perfect, beautiful, done. Fine. Good? Okay. How did Friday go, by the way? Was it okay? Me sitting here, kind of pointing it at the projector. Screen's blurry, yeah. It would be worse if I was home. My Wi-Fi at home is worse. So I figured being here might be better. So what I might try next Friday is pointing it at a whiteboard instead of at the projector. But when I tested it out Thursday afternoon, this was worse than that one. So we'll try it. You just let me know. Here we go. All right. Example 2. Let's try another one. Let's get a little tougher. Let's pick a new function too, g of x. X squared minus 6x minus 2. Same instructions. Evaluate the difference quotient. And as you jot stuff out, I don't know what this test is going to look like next week or whenever it happens. Okay, but I will give you as much advance notice as I possibly can once we get there. I'm going to point this sort of at that board over there. Okay, cool. All right. Okay, there's my question. G of x is a function, x squared minus 6x minus 2. Let's back up for a second. What kind of function was f of x, 5x plus 3? Describe the kind of function it is. The type. This one first. Linear. Yeah, linear function, right? There's no squared, square roots, anything like that. No fractions with x's on the bottom, so it's linear. So what's this one? Quadratic. The type of function it is quadratic. What shape is the graph? Very different answers, right? That's the only weird one. Linear functions are lines. Cubic functions are cubic, right? Sine graphs are sine graphs, right? This is the only one that has that weird name. All right, here we go. Well, I probably shouldn't say f of x plus h. Is this f of x? No, it's g of x. Let's stick with it, right? G of x plus h minus g of x all over h. Cool. All right. Step one, give me a function. Okay, good. Step two, start with the formula itself, and now let's just substitute. And wherever, in black here, right? Wherever I see an x in this function, I need to change that x to x plus h. All right, don't just tack a plus h on at the end. It's change every single x to x plus h. So that used to be x squared, not anymore. Now it's x plus h squared. That used to be negative 6x. Well, no, not anymore. Now it's negative 6 times x plus h. All right, I have two different x's, so I need to drop it in each of those spots. What about with that minus 2? Should I call it minus 2 plus h? Or should it just be minus 2? This says change every x to an x plus h. This term doesn't have an x in it, so it's not going to change. Okay, just a little minus 2. Good, so what's circled in black is what's in black right now. And so my numerator isn't done yet. I haven't substituted everything I need to yet. I still have to now subtract whatever g of x was and put it all over h. I try to line up my fraction bar here with the middle of my equal sign. And I'm not the kind of guy that squeezes fractions on my paper. I'm going to use 2 lines and use the line as my fraction. If you want to write, if you write small and that's okay and it's legible, cool. I have not the world's greatest handwriting, so I like to write bigger because it's a little bit easier. So do what works for you. All right, so g of x, okay, so x squared minus 6x minus 2. I'm going to go this way. I'm going to try to squeeze one more on this board. Okay, but now I have some expansion that I have to do. I'm going to erase something over here, but I'm going to turn a board. I'm going to do. Come here, Riley. Get over here. You're coming with me, girl. I can't see. There we go. Okay.
That's good.
Look how we have to start. X plus h squared. Now we did that last time, right? Was that on Wednesday? Did we talk about it on Friday? It was Friday we talked about it. Okay. And the thing that I mentioned last week, when we actually multiplied it out, x plus h times x plus h, is we got to this point where we discussed like the best way to write it so that we can combine like terms, right? Seeing hx and xh, like that order could be confusing if you don't know what you're looking for. So I said, okay, alphabetical order is a great way to avoid those kind of issues. It is not necessary. It is not going to lose you points if you switch the order. As long as it's simplified, you're good. And here's why I'm making that comment. When we expand x plus h squared, it probably takes just as much time to do x plus h times x plus h as it does to use Pascal's triangle and binomial expansion. Okay? But what I need to show you today is that, because we're going to get to cubics, quartics, powers of 6, 12, 30, right? And I don't want you multiplying all those out. What I want to remind you of, or teach you, kind of pausing this question for a quick second, is binomial expansion with Pascal's triangle. Because what you're going to see on the classwork / homework, which is listed as classwork right now, who cares what it's called? Just look at a due date. You're going to see cubics and powers of 4. And I just want you to be able to do that fast, okay? So bear with me while I teach something to you that maybe you know really well, but maybe you don't. And so this way we can all get there. All right. How to build Pascal's triangle first, right? Just a whole bunch of ones that kind of go outward to create a triangle. Each row has at most 2 ones. That's it, right? Except the top one just starts with a 1. The other thing that's important to remember about Pascal's triangle is every row has 1 extra number. First row, 1 number. Second row, 2 numbers. Third row, 3 numbers. And then 4, and then 5, and then 6. So we're missing something in the middle here, okay? And the way to find that number is to add the 2 numbers kind of diagonal above it, okay? So the number that goes in here is whatever 1 plus 1 is, which is 2. And now that row is complete because that's the 3rd row, and it's got 3 numbers, 1, 2, 1. Okay. But now this 4th row, so 1, 2, 3, 4, there should be 4 numbers here. So I'm missing 2. And they kind of fall in the windows created, like when you sit for a group photo, it's like, okay, everybody find your window, right? You see the camera between people's heads. We need to find the number between people's heads, okay? So right here, I need numbers. The number that's going to go right here is the sum of the 2 numbers right above it. 1 plus 2 is 3. This number right here is the sum of the 2 numbers right above it. So that's it. Okay, row 4, 1, 2, 3, 4 numbers. Okay, good. Now row 5 down here is missing like a number right there, a number right there, and a number right there. And so that number is the sum of the 2 numbers diagonally above it. Okay, 1 plus 3 is 4. This number, the sum of the 2 numbers right above it, 3 plus 3 is 6. 3 plus 1 is 4, and it just goes on forever. Okay. And why that's so useful for us with binomial expansion is that this gives us the coefficients for what happens when we expand 2 things being added or subtracted to a power. For us, we care about x plus h to some power. But that power can change. It can be any number we want. So I'm going to call it to the power of n, where n is just some number. It's a nice whole number. Okay. And so when we do things like, and these first 2 levels are going to take way longer than they need to, but I want you to see why it works. We're going to start with x plus h to the 0. Well, what's anything to the 0 power?
1.
Hooray! Look at the first line, the first row in Pascal's triangle when n is 0. Perfect. 1. Good. We know that one. Easy. Okay. X plus h to the first. Well, what is it? X plus h to the first. We don't have to expand anything there. Just x plus h, right? But here's why. Okay. Here we are when n is 1, right? When the exponent is 1. We should have 2 things that have coefficients of 1. 1 something plus 1 something. And this is super overkill, but when we get to x to the 7th, you're going to be really thankful that we have it, okay? Our job is to figure out what those coefficients are, and that's where Pascal's triangle comes in. But the thing that's up to us to do that Pascal's triangle can't do for us is fill in those blanks, okay? And really, we just have to decide how many x's we have and how many h's we have as we do this. And if we were to go the long way, and if I had all these combinations of permutations and I showed you the real background, I mean, it would take me a whole nother class to show you why this works. So hopefully you just believe me, okay? I'm happy to show it to you, just not while we're here. Each one of these blanks is going to have both an x and an h being multiplied together, because that's what's in here, right? You've got some number of x's being multiplied together and some number of h's being multiplied together when you do x plus h times x plus h times x plus h, forever. We just have to figure out how many. And so our job is to decide what the exponents are for each x and each h. Okay? And here's how it starts. If you've got a power of 1, that's the highest power you can have for any of those numbers. Okay? And that's how it's going to start for your first term and your first variable. This number right here will always be the same as this one. And you'll see that as we keep going, that's going to stay true. This number will always start at 0. And here's why. If your total degree is 1, x plus h to the first, the sum of the exponents has to be 1. And so 1 plus 0 is 1, and I'm good. So I've got x to the first, and then h to the 0. And as I move from this spot to the next one, those exponents are going to start adjusting themselves from one term to the next. When I take a step this way, these take steps also. The first one goes down 1. This one goes up 1. So I go from 1, 0 to 0, 1. 0, 1. Do these exponents add up to 1? Do these add up to 1? So I know I'm good. Well, 1 times x to the first times 1, okay, that's x, and 1 times h, of course, is just h. And we spent 5 minutes doing a problem we already knew the answer to. I get that, right? So don't do binomial expansion with x plus h to the first, okay? But what happens when we get to here? X plus h squared. Okay, so n is 2. How do I know that I'm on the right row? Like I've picked the right coefficients? Don't look at the first row. Don't look at the first diagonal in. Not always 1s. Look at the next one. 1. Oh, 1. 2. Okay, 2. 3. 4. The first number in Pascal's triangle will let you know what exponent you're dealing with. Okay? And so what I know from binomial expansion with Pascal's triangle is that I've got 1, 2, 3 terms. Something that starts with a 1, something that starts with a 2, and something that starts with a 1. 1, 2, 1. Those are my coefficients. The other thing that I know for sure is that in each of those blanks, I have xh. Why am I picking xh and not hx? Because that's the order that it's written in from the beginning. Okay? X, h, x, h, x. Now, I know that x plus h and h plus x are the same. 2 plus 3 and 3 plus 2 are the same. So it doesn't really matter, but I'm going to stick with the order that was given. Now it's up to me to decide what exponents each one has. The first one, that first x, will always have that power. This will always be whatever that number is. Okay? In general, when you expand x plus h to the n, that first term is always going to be 1, x to the n, h to the 0. Okay? 1, because that's always the first coefficient, x to that power, and then h to 0. So 1x squared, h to 0. And then as I kind of move along this way, every time I take a step to the next one, I'm going to adjust the exponents. First one goes down 1, next one goes up 1. Okay? So I go from 2, 0 to 1, 1. And as long as they add up to this number, I feel pretty good about what I'm doing. Okay, so 2, 0, 1, 1, 0, 2. And what do we get? Well, I'll just come down here. 1 times x squared times 1, okay, x squared, plus 2 times x to the first, okay, x, times h to the first, okay, h, is 2xh, and it's not in alphabetical order. That's okay. We have to be okay with that. If you want to make the switch because it drives you crazy, great. I'm okay with that too. But I'm happy right here, okay? Plus 1 times h squared. Now let's finish this problem. Then we'll do one with the power of 3. Questions on that at all so far? Okay, good. Here we go. Back over here. Man, I'm probably need some space. Now here's the thing. I've got all this space over here. But it's about as much space as it took me to do this one. And what am I about to do in this step? Take up more space. I'm going to expand, right? So don't try to squeeze stuff in. I don't care how much space you use, how much paper you use. I mean, I like to conserve for sure. But I also don't want you trying to write super tiny so that's everything. All right, so x plus h squared, I'm going to use that one probably from here on out because I want you to connect it better to binomial expansion than I do to putting things in the right order. Okay? X squared plus 2xh plus h squared. If you don't like that, switch the h and the x, and that's cool. But powers of 3, powers of 4, powers of 5, the x is going to come first, the h is going to come second. We're going to mess with those exponents. We're going to keep them. Okay? All right, cool. So, boom, expanded, done. Okay? This I have to multiply through, so I'm going to multiply that 6 in, so negative 6x minus 6h. Minus 2, bring that down. And then in green, distribute that negative in, so it's just going to change the sign of everything. So negative x squared plus 6x plus 2 all over h. I'll stick with the black because I think it comes up right. And down I come. I'm not going to fix it. Okay. Step 1, give me a function. Yay. Step 2, evaluate. Done. Substitute. Cool. Expand. Yay. Next, combine some like terms. What do you see up here that we can get rid of? X squared. X squared and x squared, away they go. And what do they add to? Gone. 0. Perfect. What else do you see? Negative 6x, positive 6x. What do those add to? 0. Anything else? Negative 2 and positive 2. Adding to 0 again. So when we do this combining like term step, anything, that's great math. Any terms without, W/O, without an H, should, no, will. Always, always, always. Always, 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 if you're doing it right. And all of those terms should add to 0. Okay. We'll add to 0. You can just say cancel too. We'll add to 0. Cancel out, fine. Okay. Which means that everything that does have an H is still left. Like 2xh plus h squared over h. Missed one. Minus 6h. Careful, careful. There we go. 2xh plus h squared minus 6h. Okay, now we can divide away the h, but I like to factor out that h first. So I like to take that step and say, all right, I'm going to pull the h out front here so that I can easily divide it away. And it also helps me see what's left super clearly. Because when I divide that away, I haven't touched what's inside. 2x plus h minus 6. And that means something really, really, really important to us in the first chapter of calculus. It's going to change everything. Okay, but for now, it's just some algebra practice. Good? Okay, yay. Next one, and then I'll give you a chance to start that class. Okay, let's call it example 3. Now, we got to pick a F and G. Pick another letter. Pick a new letter we haven't used yet. Blaine, give me something. Pick a letter for a function we have not touched yet. We did F, we did G. Q. Nice. I write my Q's like that. My lowercase q's. Q of x equals, what did I do? I know. Oh, I'm a fancy guy. It's like x cubed plus 1. Speaking of q's, let's cube it. All right, cool. There's a setup. The instructions are always the same. Evaluate the difference quotient. That's what they're going to ask us. All right, so I know how to start. I'm always going to begin with the formula q of x plus h minus q of x all over. Okay. All right, give me a function, wrote down the little expression that works. All right, time to substitute, time to drop in x plus h anywhere I see an x. And so it's going to go right there. All right in there. Used to be x, but no longer. Now it's x plus h. Okay. From that, we're going to take away whatever q of x is. So whatever that happened to be in the function that was given, that's the one we're going to get rid of, and that was just x cubed plus 1. Now, if you're starting to get tired of dropping in parentheses right there, if you want to, in that step right there, just say, all right, minus x cubed minus 1 without the parentheses, and take care of one step of distribution early because you're just subtracting, I'm okay with that. That's working a little fast, but the more practice you get, the easier it is. All right, all over h. All right, got to come down this way. Ham definitely has space. All right, time to expand x plus h to the third. And it's not going to be x plus h times x plus h times x plus h. That's not how I'm going to do it. We're going to go this way. I'm going to give myself some more space, though. I'm coming this way. X plus h to the third. All right, so if I'm talking about a power of 3, I pick the row. First number that's not a 1 is a 3. And that's how I know I'm in the right space. Okay. So I know what my coefficients are going to be. It's just going to be 1, 3, 3, 1. Okay, so 1 something plus 3 something plus 3 something plus 1 something. I know that's my setup. And it's 1 times, right? These are all being multiplied together. So I got 4 terms. I was going to have n plus 1 terms when you expand a binomial to the power of n. And every single one of those blank spots, there's going to be 2 things in there for sure. What are those 2 things? X and h being multiplied together. I know that I've got an x here. I'll put a dot. I don't care. You can put the dot if you like it. You don't have to for now. This is kind of our in-between work as we go. So 1 times x to the something times h to the something. Right? And that's up to us to figure out. We just need to figure out what those exponents are. The first exponent for your first term of the binomial will always match whatever the exponent is you're dealing with. So if this is x plus h to the n, so it's 1x to the n, right? This is x plus h to the third, so I know that that's got to be a 3. Those will always match. Those are always going to line up. And I know that the first exponent for that last piece in binomial is going to be 0 because I want to add up the 3, and I already used all 3. And so I got 1 x to the third h to the 0, and then I just have to start taking steps and start adjusting those exponents. So I go from 3, 0, all right, this one comes down 1, this one goes up 1. So instead of 3, 0, what do we got? 2, 1. So here we go, do it again. Down 1, up 1, down 1, up 1. 3, 0, 2, 1, 1, 2, 0, 3. Okay? Now we just make it look nice. 1 times x to the third times 1, okay, x to the third, plus 3x squared h to the first, okay, so 3x squared h, plus 3x h squared plus h to the third. And you'll get to the point where you can just walk over here and not have to look back. And building Pascal's triangle helps, because then you can just write down the coefficients for that. Does that make sense? You get the algorithm now? See it? Okay. I want that to be relatively easy once you get the hang of it. All right, cool. Don't forget the plus 1. I'll stick with the red. Plus 1 minus x cubed minus 1 all over h. This was too long. I'm going to shorten it. Make it look nice. All right, combine anything together that goes together. What do you got? X cubes. Anything else? Plus 1, minus 1. See ya. Anything that doesn't have an h is gone. Everything that does have an h is left behind. These are different, right? Cover up the coefficients. They're not the same. X squared h and x h squared are different, so they're not like terms. So I've got 3x squared h plus 3x h squared plus h to the third, all over h left behind. Factor out that h. All right. I take the h from here, it's gone. I take 1 of the 2 h's from here, so I still have 1 left. I had 3 h's here, I'm only taking 1 out, so I still have 2 left behind. So just adjust your exponents as you go. All right, so I did my combining like terms. Anything that didn't have an H is gone. Everything that does is left behind. Close parentheses. Factor it out. Divide it away. Then what you get? 3x squared plus 3xh plus h squared. Ta-da. Exploitation to the 4th, to the 5th, to the 6th, to the 7th, to the 8th, to the 9th. This only becomes more beneficial the higher up you go. Now, if you want to sit there and do x plus h times x plus h for squared, sure, go for it. That's okay. I'm not going to ask you to use binomial expansion. I just want you to expand binomials, however it works. But if you sit there and you do x plus h times x plus h times x plus h even, just to the power of 3, it's going to take you twice as long, and you're going to make 4 times as many mistakes. Okay? You feel pretty good about difference quotients? The harder they get, obviously, the harder they get. Now, the more, the more tricky the functions are themselves, the more we have to work on. So, there you go. See, I told you we wouldn't have time to work on too much stuff. So, there is something called Classwork 831 right now. August 31st, today. I will probably change the name so that it makes more sense what it's called, because we're not going to actually work on it in class. But either way, you're going to see an upcoming assignment due tomorrow. It's going to be a couple graphs. I think it's 4 like domain and ranges, and then write a function as a set of points if you can. And then I want you to try at least the first 3 difference quotients. The 4th one, now you can do because it's got an x cubed. The 5th one is a challenge that is totally optional. It's got an x to the 4th in it. And an x to the 3rd, I think. I don't know. See ya. Huh? In my heart. Yes, absolutely. Thanks, everybody. I will see you Wednesday. Huh? Did you? Where are you working? Yeah. Riley, you still there?
Bye. Thank you.
How was it?
It was good. The first
Did you
part
see?
of it was a little hard to read, but the rest was really good.
Which part was hard to read? Over here?
Board. Yeah, the very top corner, that part was a little hard to read, but you
Up
said
here.
it loud.
Okay.
Yeah, you said it loud so I could hear you, so it worked
Okay.
out.
Awesome. Yay. Okay, good. Let me stop this recording. That's awesome. I'm so glad that works. Good. I will. Let's see. Look at my face. I look so weird. Like see-through. I can't get over it. I'm recording. Maybe. Stop.